So it's recording now. And I need lesson 2. So lesson 2. Lesson 2. 8-7 math.
Lesson 2.
Thanks, bud. All right, 8-7. Can you guys see it okay?
Yeah.
Or do you want the light off? Brielle, are you okay with that?
Yeah.
Yeah.
What's it like having to walk all the way around? You can't have students go do stuff anymore.
It's weird. Okay. So weird. Okay, lesson 2. Let's get going. So go ahead and I have lesson 3 in my hand too. So we have inverse operations. We have a fact family, communicative property of addition. So let's write down those words in our vocab. You don't have to write the definition, just write it down so you know where to find it. Inverse operations, a fact family, and commutative, oh, I put too many letters. Commutative property of addition.
I thought you were talking about the one I was on. Like, how did you fix the fact that you said something else? I'm on the
Are we on associative? Oh, I forgot how many were in this one. Then we have identity property of addition. Identity. Shorten it up and say property of addition. I'm just going to say add. Then we have the additive identity.
Yeah.
I'll highlight those because I like color coding.
Yay.
I'm on Team Bethy on this one. So those are 5 of your words to get written down. And then we also have commutative property of multiplication. We have property of multiplication. We have 0 for multiplication. We have man, this one's hard to say. Multiplicative identity. Don't say that too many times. And then we have, is binary one of them?
Yeah, binary is one.
Okay, on mine's kind of faded. We have binary. We have associative property of addition. Associative property of multiplication. And that's it. Ooh, and then we get to go in perfect squares. Perfect squares is another one. So write all those down. I didn't write them all up here yet, but I'm about to. Because you guys are doing it, so I'm going to do it too. Harris, can you stop doing whatever the heck that is? So those were the first ones. Now I'm going to do property of multiplication. You can shorten them up like I am on this, as long as you know what it is. Identity, property of multiplication. Then we got the one I don't like to say. Multiplicative identity.
That's fun to say. Multiplicative.
Multiplicative.
Say that 5 times fast.
Nope. Then we have 0 for, so the property of 0 for multiplication. Then we have associative property of multiplication. And we have associative property for addition. Highlight those lovely tongue twisters. If you want to be able to shorten them, I wrote up some shortened versions up on the board if you haven't written them all down already. And then for the last one we have is perfect square.
Multiplication of 6 times.
The last one we have is perfect square. So once you guys get all these written down, I'm going to take them off and we're going to start with example number 1. Example number 1, which is on page. Oh, you got to stop. It's on page 10. How far are you guys all on? Just writing them all down. You ready?
I'm ready.
Ready? Aries, you ready?
I'm not ready.
Not ready yet?
Fine.
Jaden, how are you doing? Got all the words down? Okay. Bethy, you ready? I'm ready. I'm ready.
Are you
I'm
doing
ready.
it now, Mr. Krabs?
Okay, I'm ready.
Ready? Abby, how are you doing? Okay, almost there. All right. So if you're not all the way there yet, go ahead and leave yourself a little bit of space to write the rest of them. And we're going to start on example number 1. So we are going to name each property that they have there illustrated for us. So letter A, it's giving us 5 times 3 equals 3 times 5. So when you look at all those different properties, what do we have?
That's back family.
Okay, I found it. You guys find which one it would be? I mean, it does say there in the book too, if you wanted to really look at it.
Oh, I know.
Yes, Oasis of multiplication. Yep. And the reason it is commutative property of multiplication is because it is, first off, it's multiplication, so you know it's one of the multiplication ones. And commutative properties, let me flip to that one real quick. Commutative properties, they look like this. Write this in green. See if you guys, let me know if you can't see it, I'll use a different color. A times B, this is yellow. A times B equals B times A. So commutative property of multiplication, it's going to look like that. A times B equals B times A. Any questions on how that one is? Everyone good so far? Pretty clear? Okay. And if I were to have you guys identify these on a quiz or a test, I would let you write all of these different properties down on a note card. But if you didn't have a note card for that day, you'd be tough out of luck. Okay, letter B. This is a good one. 3 plus 4, getting into a little PEMDAS here, plus 5 equals 3 plus, in parentheses, 4 plus 5. Which one's that going to be? Caleb, which one's that one going to be? Yeah, that's the associative property of addition. Good, I'm gonna use blue for the highlighter on this one. Cha. I got you, Madeline. All right, so in parentheses, how this one's written out, A plus B plus C equals A plus 4 was B and 5 is C. Associative property of addition right there. Okay. Noise. Now I can use, no, green and yellow are too similar to me. I can't use that one. So I got to use a color I can actually see. All right. Letter C, we have 6 plus 0 equals 6. Which property do we have there? Raise your hand if you know. Aries?
Identity property of addition.
Yep. So the identity property
Of 0.
identity property of addition. So the identity property, back on, page was that? I think it's page 8.
Oh, yeah, like a sushi bar.
Anyway, we have A plus 0 equals A. So with the identity property of addition, you're always going to have your A plus 0, and it's always going to equal the exact same thing. So A. Is it?
Yeah.
Yeah,
Because he's using the highlighter.
I am using the highlighter. Oh, I didn't mean to highlight that one. I don't know why I did that. I was meaning to highlight the IPA.
Wait, IPA.
Yes,
No.
yes. We're moving on. Example 2.
That's IPA. Like,
Yes, thank you. We all knew that. You didn't have to say it. That's why I said we're moving on. But thank you for pointing out the obvious. Okay, example 2. Example 2. We got 8 plus question mark. And for question mark in this scenario, I'm going to use X. Equals 8. So, which property can we use to find the missing number? We all know that that's going to be 0, right? So which property are we using for that one? Jaden? Which property are we using for letter A? Yeah, identity property of addition. That's the one that we literally just did. Yep.
Yeah.
IPA. Good. Letter B. Letter B, we have 1 times, I am going to use the question mark this time, equals 9. So which property can we use to find this missing number? Courtney, which one do you think it is for letter B? Yeah, letter B. 1 times question mark equals 9. Which property? Yep, identity property of multiplication, IPM. So with that one and the one above it, we are just adding or multiplying it by, so in addition, we'll be adding it by 0, and in multiplication, we'll be multiplying it by 1. And you're going to get the same result. So that's when you're using the identity property. But then when we have the property of 0 for multiplication, that's when we multiply 10 times my missing number, which is going to equal 0. That is when we have the identity, or, whoops, I literally just said it. We have the property of 0 for multiplication. So with that one, whenever we multiply our number by 0, we are gonna always get our result as a 0. So that is our property 0 for multiplication. All right. What was the other main thing I wanted to show you guys? Yes, example 3. Example 3. Example 3. So for example 3, the first 4 terms of a sequence are shown below. Find the next 3 terms of the sequence. So for this sequence, I have 1, I have 4, I have 9, and I have 16. What are my next 3 numbers within this sequence? Kaylin, what are my next 3 numbers? What?
I said, thank you.
Okay.
Oh,
William, can you help us out?
okay, can I explain on the board?
Here, so I'm gonna draw an arrow right here. How did we get from 1 to 4?
So how it works,
Yeah, tell me.
the thing is, it's going 3, and then we're adding 2, which is 5. And then we add 4 to 5 is 9. Add 2 more to that 5 is 7. Now just 16.
Yep.
So add 2 more to that 7, it would be 9. 16 plus 9, 25.
Yep.
11, 36.
Yep.
And 13, 49.
Bingo. You said 49, right? Not 39? Okay, just making sure.
I'm bad at those.
So what was our difference here? We are going up by 3 every time, but in between, so each number, we are adding a 2.
And like,
So to go from 1 to 4, we just were going up by 3. But the difference of 4 to 9, there's a difference of 5. So what did we do here? We added 2. Is that going to be true for this next one? Yes, we went from 5 to 7. We added on 2 more numbers to this number sequence.
that's fun to do.
It is a fun one to do. Does that make sense how we got there? Bethy, Courtney, Jaden, Abby,
Yeah. Oh, yeah.
Caleb? Yeah,
Oh, yeah.
all good? Sweet.
Is that called area?
Yeah. Yep. So another way with this one would be, so
Start with 3, each time you add 2.
another way to explain this would be,
Here, if you put a plus 2
Oh,
between 2
no,
and 5.
here we go.
5 and 7.
so this is where we have the perfect squares coming into place. That's the word I was looking for, perfect square. So another way of looking at this is we have 1. So we have 1, and then when we go to 4, this is just going to be 2 squared. 1 squared is 1. Then when we have 3 squared, we have 9. When we have 4 squared, what's that going to be, Abby? What's 4 squared, or 4 times 4? So we have 4, 8, 12,
I see what you're saying.
16. So this is also how we do perfect squares right here. So after 16, so then we have 5 squared. What's that going to be, Oasis?
5 squared would be 25.
25, bingo.
You thought I wasn't paying attention.
No, I was just asking you. Jaden, what's 6 squared going to be? So what is 6 times 6? Yeah, 36. Yep,
No, 6.
yep. And then we have 7 squared. What's that going to be, Courtney?
49.
49. Good. Does that help a little bit? So what we're doing here, have you worked with exponents before, Abby? Yeah?
I don't understand.
So what you're doing, so I'm going to go to a completely different page here and I'm going to help explain exponents a little bit. Clear all my drawings. Okay, so whenever you see, let's say, the number 1 squared, that little 2 up there, it's saying I am taking 1 times 1, and that's going to equal the number 1. For 2, I'm going to say 2 times 2. What's that going to equal, Abby? Yeah, 4. Yep. So for 1 squared, that's going to equal 1. 2 squared, that's going to equal 4. For 3 squared, how would I write that out? Like I did down here. So for 2 squared, I did 2 times 2. 1 squared, I did 1 times 1. How would I write 3 squared? Take 3 times itself. So this just means there are 2 3s. So I'm going to say 3 times 3, and that's going to equal 9. Hey, Caleb, what are you doing, buddy? Why? Sit down, dude. Go sit down. I don't know what you're doing. 3 times 3, that's going to equal 9. No, go sit down, dude. Then I have 4 squared. This is your math. So 4 squared. Bethy, what am I going to do to figure out what 4 squared is? What's another way I could write that?
4 times 4.
Yeah, 4 times 4. So I have 4 times 4. And Bethy, what's that going to be?
16.
16, good. So 4 squared equals 16. 5 squared, Oasis, how would I write that out?
5 times 5.
Yep, 5 times 5. 5 times 5. And that equals what, Oasis?
25.
Bingo. Courtney, 6 squared, how do I write that out?
6 times 6.
Yes,
Right, so
6 times 6 equals 36. So I'm going to do another one here. Let's do 9. 9 squared. Oh, Aries, how do I write that out?
9 times 9.
9 times 9. And what does that equal, Aries?
81.
81. Good. Yes. And Caleb, how do I write 10 times 10 out? Yeah, I gave you the answer there. 10 squared is 10 times 10, which is 100.
Wait, no, it's 200.
No. And then how would I write out 11 squared? Jaden, how do I write out 11 squared? Are you napping? Are you awake with me?
I got the Nerf gun.
I got the Nerf gun.
You mean?
How do I write 11 squared? William, can you help us out? How do I write out 11 squared?
11 times 11.
Yep.
Which is
21.
I believe.
Yep.
So basically what we're doing, Abby, is, so if it was 9 with a 1 on the top of right corner, it would just be 9 times
1, which
Okay,
is,
but if there's a 2, you're basically multiplying the number twice by itself. There's 3, you're multiplying it 3 times by itself.
so it'd be
9 times
9 times 9 times 9, exactly. Yep.
That's basically how it works.
Yep. So, and what these are called right here is these are all perfect squares. These are all perfect squares because we're multiplying it by itself, which makes it a perfect square. Because eventually we're going to get into square roots. And when that's kind of more pre-algebra. So when I take the square root of 81, what's that going to be, Logan? If I take the square root of 81, have you done that yet? Yeah, 9. So what Logan did, that's a perfect square. So he took 9 times 9, and that equals 81. So my square root of 81 is 9. So that's when we get into square roots. That's my perfect square.
And then when you taught us something last year, but I forgot, if there's another squared sign right on the page again.
Yep, that would cancel it out.
Wait, would that be 3?
So you're saying if there was a squared,
Yeah, right there.
so that would cancel out your square root and your square because those cancel each other out.
It would just be 81.
It'd just be 81. Yep. But we're not doing that right now. That's just kind of what we're getting into. I just want to show you guys that. Okay, so I'll let you guys get into your homework. That was good.